Hi everyone, this is Shravani from WRI. Good afternoon everyone, welcome to the webinar. I'm so happy to see such an amazing participation and would like to thank all of you for attending this webinar and for all your time. First of all, let me introduce you a little bit on the webinar series. This webinar series is a part of the project, the Electric Mobility Forum, funded by our kind supporters, the Shakti Sustainable Foundation. This project was launched by the Vice President of India on 28th of March 2019. As a part of this project, we organized various webinars on very crucial topics revolving around electric mobility, along with many other activities such as workshops, opinion pieces, blogs, etc., which also are very focused on specific topics, again, around electric mobility. So a little bit about the past events. So we successfully completed 2 of such webinars with topics on standardization and retrofitting. So far, we have been doing it on very focused topics and received wide interest and participation from not only people from India, but worldwide. Thank you for participating, all of you. But when we speak a lot about these really specific topics and converse at the same time with the other participants, so we received a number of, queries and public requests to do webinars on batteries and some really specific topics. So I think it's a great chance for those of us who already know about these batteries to touch base on our basics, and for those of us who are still learning, it'll be something new for us to learn as well. So now, why this topic out of so many? We all know that issue of air quality around the globe, and many countries, including India, have made promises in terms of policies and products to tackle the rising problem of air pollution. We'll be surprised that 23% of the global GHG emissions are from the transport sector, and 70% of the emissions come from the cities, which has a lot of vehicles in them. Air pollution is linked again to 6.7 deaths worldwide, along with many diseases such as respiratory problems and lung cancer, etc. Out of many sustainable ways, electrification of transport is one of the mediums to tackle the problem of air quality. Although there have been many efforts in our country to promote these vehicles, there are still major anxieties such as range anxiety and charging infrastructure, which acts as a speed breaker to the adoption of this new technology. We all know that batteries are the heart of these vehicles, meaning the maximum cost of the asset is due to these batteries. The safety aspects also depend a lot on these battery technologies as well. If this is such an important part of an EV, is it not necessary for us to know how to choose the right kind of technologies as consumers so that we are profitable from the purchase and yet are safe? Hence, we have Dr. Parveen Kumar working on EVs in WRI-India this time, who will help us do a run-through for batteries and solve the anxieties and myths related to the same. I hope that he will be able to make a smooth transition from why the shift is necessary from ICE to electric, and what are the things that we need to keep in mind while choosing one. Well, before we start, a few important points that I would like to make is that this webinar is a 1-hour session, which includes a presentation by Dr. Parveen and is followed by question and answers from the participants. So I request you to kindly type in your questions in the questions box and not in the chat box. We'll try to address them as much as we can, depending on how much time is left. If you have missed out on any points and if you're busy taking notes, please don't worry about it, because we'll have the presentation and the video uploaded in the same link that you have registered as soon as we finish the webinar. Now, before handing it out to Parveen, I would like to run through some of the topics that we would like to touch base upon before starting the webinar. So the key discussion points that you have already seen in the registration link are that which of the battery type is the most preferred for electric vehicles? Why are these batteries the most preferred choice of electric vehicles for the application? So in this, we'll be talking about safety and technologies and chemistry and whatnot. Then we'll also cover the fact that how safe are these batteries, and if we know what we need to do in terms of hazards and whatever, like in temperature and etc. Like Parveen will be sharing more about all these things in detail. And what is the future of these batteries of EV applications? Also very, very important, last one is what are the environmental impacts of these preferred batteries? So now I would like to transfer it to Dr. Parveen. Welcome, Dr. Parveen, to our webinar, and I hope you'll be able to help us clear our myths, anxieties, and questions related to electric vehicles, batteries, so that we are happy consumers and customers and can choose the right type of technology for electric vehicle adoption.
Thank you, Shravani, for giving and summarizing the important points related to this topic. So before talking about batteries, in next few slides, I will discuss about few basic information about electric vehicles, battery, and its comparison with the gasoline powered vehicles. So electric cars have long history, and it starts from late 1800 after the invention of rechargeable lead-acid batteries and electric motor. In early years of 1900, the number of electric vehicles was almost double than that of gasoline-powered vehicles. But by 1920, electric cars almost disappeared from the market, and the market was completely dominated by gasoline-powered vehicles. The main reason for this EV to ICE transition was heavy weight, short trip range, long charging time, and poor cycle life of the battery that time. But now once again, EVs are ready to disrupt the automobile sector thanks to the environmental concern due to the usage of gasoline, high cost of gasoline, and issue of energy security. So now let us understand the components of gasoline and electric powertrain. So in gasoline powertrain, IC engine is powered by gasoline stored in simple fuel tank, whereas in electric powertrain, electric motor is powered by charge stored in battery. The amount of energy stored in battery strongly depends on the battery material. So in this transition from internal combustion engine to EV, we are shifting to complex IC engine to simple electric motor, where we are shifting from 20,000 moving parts to less than 20 moving parts, and this reduces the maintenance cost by a significant amount. So in this in case of if you compare the fuel tank, so in case of ICE, we have a fuel tank made up of fiber or the steel, where you can just store the gasoline and use in the vehicle. But in case of battery, we need to store a charge in the battery, and we have a limitation that how much charge we can store in the battery. So in this transition from ICE to EV, we are shifting to complex ICE engine to simple electric motor, as I mentioned. But on fuel side, we are heading towards more complex system. EV batteries required to handle high power and high energy capacity within a limited space and weight at an affordable price. It is important to understand the limitation of the battery systems to utilize them in the best possible way. So in terms of efficiency, in terms of performance, the efficiency of electric vehicles is 5 to 6 times than that of ICE vehicles, but the energy density of gasoline is almost 100 times than that of battery. And this is one of the major R&D problem for the researchers, how to increase the energy density of the batteries used for EV application. So before discussing more detail about the battery, let us understand few important performance indicators. So energy density is the amount of energy stored in the container, and this is important for the drive range. Power density means how fast battery can release the stored energy. The safety, cost, and battery life depend on the battery material used and its operational condition. And the environmental impact of the battery will depend on the material used in the battery and its recycling potential. For example, in case of lead acid battery, we are using a lead which is a toxic element, but lead acid battery is having a very good recycling potential. So environmental impact will strongly depend on the battery material. So now we'll see how the battery evolved since late 1800. So as I mentioned in my first slide, that the journey of electric vehicle started with the lead acid battery. After some time, other technology emerged as a possible alternative to lead acid battery. So in this slide, I have listed pros and cons of each battery option. For example, the major advantage with lead acid battery includes low cost and its good recycling potential. And the major disadvantages are low energy density and toxicity of lead and weight of the battery. Currently, the electric vehicles are powered by the lithium-ion battery. This is due to its high energy and power density, and this is the most preferred battery for the EV application. For future, lithium air battery appear as a possible alternative to existing lithium ion variants. So why lithium batteries a preferred option or preferred choice for the EV application? So the key performance requirement from the battery for EV application includes high energy density, long cycle life, lightweight, and small size. On this key performance requirement, lithium-ion variants emerged as a best candidate. Lithium-air battery, which is one of the lithium-ion variant, is having very high disruptive potential due to its very high theoretical energy density. So now let us look inside the lithium-ion battery to understand how complex is this container which stores the charge for our electric vehicle. So in lithium battery, many single cells are arranged to form the cell. Cells are arranged to form module, and several modules are arranged to form battery pack. In this packing, units are arranged in series or parallel to tune the capacity and voltage of the battery. As the safety is one of major concerns of lithium-ion batteries, battery management system is included in each battery pack to monitor and protect the battery during operation. So now let us understand how basic unit of lithium battery, that is cell, works. So we know that battery converts chemical energy directly into electrical energy. Batteries have three major components: is cathode, anode, and electrolyte. During charge discharge, lithium ion travels between cathodes and anode via electrolyte and charge through the outer circuit. In case of lithium battery, we have several options on the cathode side. So one is the lithium cobalt oxide, which is mainly used in the mobile phone batteries. Then we have a nickel cobalt aluminum, that is NCA, nickel manganese cobalt, that is NMC, lithium manganese oxide, that is LMO, lithium iron phosphate, that is we call LFP. And mostly these cathode materials are used with one of the anode material, that is graphite and LTO. Currently, graphite is the most preferred anode material in the lithium-ion batteries. But each battery composition have some limitations. So based on the requirement and application, one can select the cathode and anode material. So in this slide, I have summarized the key performance parameter of different lithium-ion variants. So in case of lithium iron phosphate, you can see that this can give a very high safety, but one need to compromise on the specific energy and performance. So it's very important to understand the application, limitation of the battery, and that will help in choosing the best chemistry for a selected application. So making good battery is a big challenge. So it requires balancing key performance parameters and managing many trade-offs. So as I mentioned, one can use LFP with the graphite anode. This can offer relatively better safety, but one need to compromise on the other performance parameters. NMC with LTO can offer long cycle life, stability at high charge discharge rate, but high cost and weight of the battery will become issue. In short, each option comes with some pros and cons. One can choose lithium-ion variants as per requirement. So now we'll discuss the few important points that is related to the uses of the lithium-ion battery. So one, we'd like to understand how temperature can influence the performance of the battery. Earlier I mentioned how lithium battery works. So during charge discharge, lithium ion travel between cathode and anode via electrolyte. With increase or decrease in temperature, cathode or anode materials may undergo irreversible structural change, which in turn can influence the performance of the battery. To ensure best performance of the lithium-ion battery, it is important to operate the battery within the optimum temperature range. For example, at very low temperature, batteries don't achieve their full rated power until the battery cells warm up. At very high temperature, they lose their ability to store energy. Hotter the temperature, the faster they lose their storing ability. So in this slide, I have summarized how C rate, SOC, and DOD can influence the battery performance. And we often discuss about this, that this particular lithium ion variant we can use for high charge discharge rate. But one need to understand how this choice or selection of charging discharging can influence the battery life or cycle life of the battery. So C rate is the rate at which battery is charged or discharged. So with the high discharge rate, the battery cycle life decreases. The other important point which we usually discuss about the state of charge. So state of charge describes how full a battery is. And the depth of discharge measures how much of stored energy is used at each cycle. So one can tune the cycle life of the battery by adjusting the DOD, that is the depth of discharge. So if you select low DOD or depth of discharge, one can increase the cycle life of the battery, but it comes up with some other problem. That if you want a particular capacity for a selected application, and if you reduce the DOD of the battery, then you need to take a big battery pack to achieve that battery capacity. So there is a trade-off with the cycle life and the battery pack size. Because if you size a big battery pack, that will increase the cost of the battery. So while selecting the battery for the application, sizing of the battery for the application, one need to see the several trade-offs, and then one can select the battery for the application. So one of the major concern is related to the safety of the lithium ion battery. So I mentioned earlier that in lithium ion variants, there is a cathode, electrode, cathode and anode, and in between this we have a non-aqueous electrolyte, which is flammable. So in any abuse condition or battery failure can lead to the material degradation, and which in turn can lead to thermal runaway. So what is thermal runaway? So thermal runaway is a catastrophic event causing uncontrolled temperature to rise during cell operation and release of large amount of heat energy. And this process we can divide into three stages. Stage 1, the issue like lithium dendrite, separator flaws, overcharge, cell crush can initiate the material degradation, and this will lead to the increase in the temperature, and with increase in the temperature the SEI, the solid electrolyte interface, may decompose, anode material may decompose, and this will release the gas and increase the temperature in the battery, and this increase in the heat oxygen can combine with the non-aqueous solvent, which can act as a fuel, and this can lead to the thermal runaway, and which can finally lead to the explosion in the lithium battery. To avoid this situation or this event, almost all the lithium battery contains the battery management system. This is the electronic system, and this monitor each and every cell in the battery and protect the lithium ion battery during operation. So in this slide we'll discuss that what are the R&D opportunity where academic institution, industry and the other relevant stakeholders can play the important role. So I've just divided the opportunity into the three separate buckets. What is the innovation in the lithium battery technology? So what is the objective? We want to increase the energy density and power density of the battery. We want to improve the safety issues. We want to address or remove this safety issue. So what need to invest time on development of novel electrode and electrolyte material, which can help in addressing the concern related to the lithium ion battery. The charging time is another big issue with the lithium battery, and nobody wants to invest long time in charging the electric vehicle. And I mentioned that how fast you can charge or discharge the battery will have a big impact on your battery performance and safety. And as the battery accounts for more than 50% of the total cost of your vehicle, is a big investment. So nanotechnology can help in improving the performance of the existing lithium battery. So one other concern related to the lithium ion battery technology is the availability of the resources, the toxicity of one of the element used in the lithium battery. So lithium is available in a selected geographical location, and that is creating a big concern in some of the area or in some countries. The toxicity of the cobalt is the other issue. So researchers can help in exploring a new battery technology, or I can say the alternative to lithium ion battery. The other possibility is there the innovation using hybrid technology. So one can explore, is it possible to use the pros of two different battery systems and compensate the limitation by using the other battery technology. For example, one can explore the lithium ion battery, lead acid hybrid, lithium ion battery with the supercapacitor, lead acid battery with the supercapacitor. So this slide, what are the important things I mentioned, like novel electrode and electrolyte materials we need to develop to achieve high energy and power density while addressing the safety concern of the lithium ion battery. And one important development can be the development of solid electrolyte, which can help in addressing the safety concern of the lithium ion battery. As I mentioned, the degradation of the cathode or anode material releases the oxygen and heat, and the presence of non-aqueous solvent act as a fuel, and that lead to the thermal runaway, leading to the explosion in the battery. So if we can develop a solid state lithium ion battery, it will not only address the safety concern, but this will also help in making the lithium battery more compact and lightweight. But the other option is the development of new battery technology. Here basic R&D can play a very important role. In literature, we can see there is a talk about the lithium, sodium ion battery, magnesium ion battery, iron battery, but these are at very basic level, and there is lot we need to do to develop a cathode and anode material for these batteries. So one very important thing which we can do in a short term where we can explore how we can combine the two different battery systems to achieve the required performance. So for example, I have summarized here that how the fuel cell and battery can be used together to achieve a required performance, and even the fuel cell can be used with the supercapacitor. Lithium and battery and supercapacitor hybrid can be explored. So there is a way to address the some of the concern in short term by doing innovation, by using the hybrid technology approach. So one of the very important thing why we are talking about transition from ICE to EV. So when we list the reason, the first thing we discuss global warming, climate change, air quality issue in the cities. But while doing this transition, we need to understand that if we want to achieve our target in true sense, we need a very robust and efficient recycling ecosystem for EV batteries. And to establish this ecosystem, we need the government organizations, industry, and the R&D institution to work together to make this happen. We also need to utilize the resources efficiently. R&D can help us in replacing the toxic materials from the next generation batteries. Another important thing, the use of green technology for battery manufacturing. We need to avoid the solvents, which is not good for the environment, and researchers can help in explore the alternative which can help us in minimizing the negative impact of the existing approach. The one of the important thing that when we are moving towards the EV, we also need to integrate the clean source of energy. We need to integrate more renewables so that we can achieve our objective of low carbon. And if I can summarize, we need to move from linear economy to circular economy. This I complete my discussion, and I'll hand over to Shravani.
Thank you, Parveen. This was amazing. To be honest, like we keep on attending so many conferences and webinars, but there were actually a lot of jargons which I'd never understood, and today you made me, like think about all of them, and such nice infographics as well. So pictorially, you also depicted many important topics, and also made us understand the pros and cons of every technology and everything. I think it was quite beneficial for myself, and I hope that the audience is being able to benefit from this as well. So, Praveen, I see there are like so many questions, but because of some time constraint, we'll try to take as much as we can. We have a question here, which is like from slide 1, it seems. That means where you have mentioned the history of how EV transformation started. So the person asked, like, we're still discussing the reasons listed for EV to ICE transition in 1920 as a barrier in EV adoption. So what is your comment on that?
This is a nice question because when we are talking about ICE to EV transition, and when we list about the barriers in EV adoption, we talk about the drive range anxiety, long charging time, and anxiety associated with the battery technology. Because battery accounts for the 50% of the total cost of the vehicle. And if anything happens to the battery, or if battery is not able to give the same comfort what the consumer is getting from the IC vehicle, this is a big barrier for the consumer to shift from the ICE to EV. But we need to understand that since 1800, late 1800, that is 1815, battery technology has improved from very low energy density to very high energy density. Weight also, if you compare the weight of lead acid battery, is much higher than the lithium battery. And as I mentioned, that high energy density, power density, and the weight, the size is the key performance criteria one need to think before selecting the battery. And now we have a lithium, which gives us not all, but most of the what we expect. And with the time, this technology will improve. And as I mentioned, like lithium air, which is having a very high theoretical density. A lot of research is going around that. There are few concern in that. So researchers are working. And if that is available for the EV sector, so I think all of the concerns will
vanish. That's great. Thanks, Praveen. Let's take the second question. I think this is like quite an interesting one. It says, currently, e-rickshaws are powered by low-cost lead acid batteries. So then why should they shift to lithium-ion batteries? And as we could see that it is of high cost at the moment. So, like one of the other concerns is like, see, there are like two different business operating models. One is that the company owns a lot of fleet, and some of them are like individuals owning their own fleets. So, imagining their income groups, so this could greatly affect them, like their decision on purchase, etc., because the asset cost is going to get like really higher because of the choice of battery. So how do you think that we should take care of that, and why do you think that they should shift from lead acid to lithium ion?
So as I mentioned, like the energy density of lithium-ion battery is much higher than the lead acid battery. So, and also the weight is very less compared to the lead acid battery. So although the cost is high compared to the lead acid battery, but the gain you get from the energy density and the weight and the performance will offset these concerns. So you may need to pay high cost in upfront, but when you calculate over the time, so you need to change the lead acid battery in 10 or 8 or 10 months. But lithium ion battery you can use for 5 to 6 years or 7 years if you use wisely and if you understand what are the best conditions for the lithium battery. So here I feel that the OEMs and the manufacturer of the battery should come up with some business model which can address these concerns. So in some of I came across some startups. So they are giving a battery to e-rickshaw on lease. So this can be one solution. So this may address but we need to educate more about this, that you should move to the lithium battery unless you have a other battery option. So definitely you can, because weight of the battery makes a lot of difference on the performance of your battery. So personally I feel that lithium ion battery is better option. And if you calculate the total cost of ownership with the lithium battery, which is much less than the lead acid battery.
Right. So you're saying that, like proper awareness and then doing the TCO and also like having innovative business models can take care of the problem in the long run.
Yes.
So it shouldn't be a problem. Shouldn't be worried about that.
You're right.
Yeah. Great. So this is another interesting question. So we see that a lot of standards or studies or like the things that we talk about are always kind of taken from the Western countries or like the studies done from the West. So like most of these countries where the EVs are mostly cold countries, right? Like even in China, the temperature is comparatively colder than in India. So what do you think? Like, let's take an example of Delhi. So it gets like 48 degrees and we're like all dying and scorching in heat. So how do you think that these lithium ion batteries are like safe, to handle in this kind of temperature? Because obviously that we know that the lab conditions and the real lab conditions are completely different. So what do you think that what are the things that we should keep in mind to ensure utmost safety when handling such complex batteries? And what should be done in the longer term to, complement the Indian temperature along with the battery chemistry and the choosing of the technology?
So this is a very valid question, and we have seen that, as I discussed, that temperature is having a very significant impact on the battery performance, battery life, and the safety concern is also associated with this. So in big vehicle like car and the bus, there is an option to use the cooling mechanism for the battery. In case of small vehicles, two-wheeler or three-wheeler, usually go for the passive cooling. We use, manufacturers uses the phase change material or something to control the inside temperature. So as I mentioned, one need to understand the limitation. The OEMs need to do the capacity building or discuss with the users that how they can address this issue of temperature. So one can be that charge in a controlled environment. So safety will be not a big issue, I can tell right now, because there is a BMS on the battery which can sense the temperature of each cell, and if there is a safety concern.
What do we mean by when you say like charge in a controlled environment?
So if you have a battery having internal temperature very high, so you need to cool the battery at the room temperature. That time charge discharge will be more efficient. So if you try to charge at the high temperature, battery will be not able to absorb that charge. And the battery that can lead, if you charge at the high temperature, internal temperature, that can lead to the degradation of your battery material. So when you are thinking about charging, discharging, I personally feel that we should have a mechanism where we can charge the battery in a controlled temperature environment at the room temperature. And I think OEMs and the battery supplier will be able to provide some best option to address this temperature issue in some selected cities like Rajasthan, Delhi, or we can say in the North India. Because the low temperature is also the other concern where your battery will be not able to accept the charge as they have the rated capacity.
Okay, great. So we've got another question. So this is something that concerns even me as a consumer, like if I want to buy an electric vehicle. So the question is, what if lithium ion battery fails within 1 or 2 years of purchase? And also like, by failure, how do we define failure of these batteries? And imagine like I bought the battery and the electric vehicle and it fails. who takes the responsibility if I don't own a private car, and if it's a bus, or like how does it change from mode to mode, like responsibility wise, and what happens if there is a massive failure, and what do we mean by failure?
So battery, yes, the battery failure I mentioned that maybe due to the some issue with the material or due to some abuse condition or some accident. And if something happens, there is a ways where can lead to the battery degradation, some defect inside the battery, like an internal short circuit, or there is a anything is punctured the cell. This kind of event can lead to the battery failure, or if you are charging, discharging without understanding that whether that battery material can hold, can support that charge discharge. This can lead to the failure of the battery. But your concern is right that as a consumer, if I buy the lithium ion battery and if I calculate my cost that this battery will last for 7 years and it fails within a 1 or 2 years. So here I feel that the battery manufacturers and the suppliers need to play a major role. And as I mentioned that the innovative business model is required. So at this stage of EV adoption, the role of battery suppliers or the manufacturers, the vehicle suppliers becomes more important.
Do you think like the insurance company should also start looking at new policies, and also like probably warranty periods could be a good incentive for consumers like us to buy electric vehicles and not think about like, oh my god, what happens if the battery blasts, or like if there's a disaster, where does my money go? So there should be some assurance, I think, in the initial phases of purchase, and probably then yeah.
But this is the good option. But when we discuss even the finance, banking sector and non-banking finance organizations, they are not that enthusiastic in giving a finance. I don't know about the insurance. If the here also like battery manufacturers or the suppliers and OEMs need to come up with some plan.
Yeah.
I don't think at this stage insurance companies will come forward.
Yeah.
But if they come, it's good, because if you give assurance to the consumer that if your battery fails and he or she is not responsible in that failure, there is a technical side that he or she will be compensated with something. So I think insurance thing will come later, but the manufacturers and OEMs need to come forward at this stage.
Okay, due to time constraint, we'll take the last question over here. So it says like, see, there are a lot of talks happening about, and in every 3 months, I think there's a change of technology and everything, right? So now at the moment, we're like extremely and entirely religiously focusing on electric mobility. However, in other parts of the world, electric mobility is already done, and they're looking at like other forward-looking technologies. And I think it's going to come to India as well, sooner or later. So do you think it's going to be like a disruption, or like what if new battery technologies come into the market? What happens to all the investments, policies, and efforts in research and development? So how do you think that we should go about like tackling this uncertainty about new disruptive technologies, either for batteries or any other sustainable mode of transportation, technology-wise or fuel-wise?
This is one of the major anxiety for the consumer and for the OEMs and the battery manufacturer. This concern is on the other side. That if I'm investing so much money in the manufacturing of a particular technology, what happens if there's something new is coming? But one need to understand that from battery at the R&D level, or you can say the technology readiness level at 2 and 3, it takes long time to come into the market. So there is some performance requirement you need a energy density, power density, then you need a good cycle life, then safety, and then summary of all that, you need a low cost option. So you need a battery technology which can offer all these things better than the lithium. So as per my understanding, I see the lithium and battery is going to stay for next 5 to 8 years. Most of the innovation will happen in the hybrid, as per my understanding, where people will be playing with the lead acid battery with the supercapacitor, lithium ion battery with the supercapacitor, using the innovative way to get maximum out of the existing technology. And if new technology comes, which is different from the lithium, so of course the manufacturers need to invest in that, and we have seen that we get every year the new model comes, the new model of the vehicles comes into the market. So it's not like the new technology will come and replace the old one. So there'll be a gradual transition. So I don't think this is a very big concern, and this is important right now to promote the innovation, because as is showed in the second or third slide, that there is a huge gap between the energy density of the gasoline and the battery. So we need innovation, but this should not be act as a barrier in the EV adoption.
Great. So I think you're saying that we shouldn't be worried about it, and new technologies take a lot of time to come and settle down, especially country-wise and state-wise. So we still are good with electric mobility at this point of time.
If they come, there will be a phase-wise transition. It's not like now in the case of EV. You can't expect that all the IC vehicles will be replaced by the electric vehicle. It will take time, and you have to remove the phase battery. So same thing will happen if any new battery technology disrupts this battery market. So you're right.
Yeah, so there'll always be a place for everyone in the market, provided we provide them proper skill development, capacity building, and research and innovation. Great. So I think we are done with giving so many great information about battery technologies from Praveen. So do you have any concluding remarks, Praveen? Like, we have 3 more minutes, so if you want to say something.
I would like to thank all the participants and to you to summarizing and raising the sharing the questions from the participant. And in this presentation, I have just tried to cover the broad picture of the whole thing. We can discuss more about the individual thing, like performance related to the battery or recycling. This itself is a very big topic and very important topics. So we need to discuss this in detail. So if you...
No, I completely agree. Like each slide could be like research topic in itself. Anyway, so let's conclude. Thank you all the participants for sparing your precious time and taking out the time to learn about batteries with us, with WRI-India. I would like to also thank Shakti Foundation for giving us this platform to be able to disseminate such knowledge to everyone. And so as soon as we finish this webinar, we're going to upload the presentation and the video of the same. So if you have missed out on anything, please don't be worried. You'll have all the details in the video and the presentation in that link. So there's not going to be a new link. In the same link, it's going to be uploaded. That's all for today. We'll come up with a new topic, hopefully next month, with something more focused and detailed, and we'll keep you posted. And hope to see you on the other side next time as well. Thank you, guys. Bye.